for sure. So please make sure to make the most of it. If anyone has any questions, please put them in the question box. We are very happy to answer any and all of those as they come in. If we happen to not get to them today, which we will have a Q&A at the very end of this, we'll be happy to get to those at a later date, or emails or phone calls, or however you'd like. That's for certain. So again, we're happy you all can join us. We can't wait to teach you guys about all the innovations we have here with ground penetrating radar. Again, it's myself. I'm Daryl Stanyard. I'm the regional sales manager for the US. And I have also Hussam, who is our head of product management for all of infrastructure, not just GPR, but all of things concrete. So he is he's our head guy. He's the one who innovates all of this. So he's gonna lead all the slides here for us and make sure that we are well aware. But again, just want to take a few minutes, make sure we can get everybody in here we can. And then we're going to start the slides. So again, any questions, anything you have, any concerns, please put them in the question box. We'd be very happy to have that for you. We're going to answer all of those, whether they're today or another day. We'll make sure to get to them. That's for very certain. Hey, Hussam, real quick, I have a question for you.
Yeah, tell me.
How do pirates find buried treasure?
Yeah, pirates.
How do they find buried treasure?
I think they are using GPR.
GPR. Sorry, as corny as that is, we just want to make sure we keep the audience in check here. Let's everybody have fun, be attentive, and enjoy this show. That's what we're here for. So,
What time is it in Pittsburgh?
it is 12:03, just after noon. So we got a lot of people eating lunch right now. We don't want any hangry guests. So if you haven't eaten yet, hurry up and eat, and then join us, because we don't want anybody who's hangry.
Okay, so let's start.
Again, our hosts here are myself, Daryl, and Hussam, and we're here to just talk you through this. So a little bit about Screening Eagle Technologies. A lot of you here in the States, and meaning the US, know us as ProSec, which we still are. ProSec is the manufacturer of the hardware, where Screening Eagle is the combination of the hardware and our software and what we're able to do with that. So again, we've been around since 1954, 300 plus employees. We cover the entire nation, the entire world, not nation. And we are able to do that, as a group. And so we're not the new guys on the block, as some may think. GPR has only been 6-7 years, but as a company, we've been around forever. Today, we're going to go through the 3 different GP models we have. So we have 3 concrete GPR. So we have the GP 8800, which is on your left, the GP 8000, and the GP 8100. So all very powerful tools for concrete. The 8800 is ultra high frequency. So I know Hussam is going to cover this later, but 6,000 megahertz, very, very detailed, and the data it's going to collect, as well as goes down to 400. So also able to go very deep in the concrete. The GP 8000 is more of your standard 4-wheel GPR people are used to seeing. Again, 200 megahertz, so very deep in the concrete. I think he'll touch on this. Currently, as we speak, I think it's up to 32.5 inches deep. But I think Hussam is going to tease on something else. Up to 4,000. So 4,000 also being very detailed in the top of the surface. And then we have an 8100, which is an array. So the 8100 is a 6 sensor array of GPR. So what we have is basically the GP 8000 in the middle. If you go to the 8100 on the right, that is a six times that. It's only 3 times the width, but it has 6 times the antennas. So it's able to see much more, give you real 2D scans in time, and so on and so forth.
Thank you, Daryl, for this nice introduction. So here, I really want to first address this nice educational webinar for not only for beginners but also for experts, because we have serious things here. I would say even a gift, some uniqueness for the first time in a world of handheld concrete scanner, GPR scanner. So first, I will start with the challenges. We know that the construction industry is more and more demanding, getting more and more demanding. I will dedicate a bit of time on the principles. I mean, that's always good to start with fresh reminder and on the knowledge. I will present in detail the advanced solutions that we have today to address to those challenges in construction industry. And then I will present to you some nice use cases at the end. I'm sure you will enjoy it. As you know, the challenges are really big in construction industry. We have more and more complex, buildings, tunnels, bridges, not only existing ones, renovation, retrofit, and also new ones. We have so many objects now in the walls, in the slabs, with internet, boom. 20 years ago, 30 years ago, we need more and more objects, plus also the structures challenge, PT ducts and rebars. And when you drill, you core, you touch very critical object, you have a huge cost. And we know that all our partners, friends in US, for instance, they really have a huge liability, responsibility to handle that. So that's our duty to really provide solutions to help you in that matter. On top of that, we have all the structural assessments, which also are required in retrofit projects, for instance. You need to know what's inside the structures in absence of shop drawings. And even for new constructions in the site, in the field, even after pouring concrete, we still see, of course, a good quality management. They want to inspect, they want to be sure what's inside. Is it at the right place or not? And the complexity today of layout make it really mandatory. So GPR, what is GPR? Ground penetrating radar. So basically you need an antenna, and what is an antenna? You need a transmitter and a receiver. So you send an electromagnetic wave with the frequencies that you saw with Darren, and the wave is getting back when it bumps, it reflects on an object. So transmitter, receiver, and you need also encoder if you're dynamic. Now, I just want to explain hyperbola. Many of you knows, but just a quick reminder, why do we have an hyperbola? Because you're moving. And when you're moving, you have a different distance between you and the object. And you have some long distance, short distance, long distance when you get away from the object, which explain this hyperbola shape. And the good news for concrete is super nice because it's homogeneous first. And the good news, we have 100% reflection on the metallic targets, which makes it easy to detect metallic targets. But not only metallic, as you know, you can have also a good reflection, not 100%, 50, 60, 40, depending, air, plastic or wood or something else. You can also have a good layout of other objects. Now, that's always good to refresh our mind. A scan, B scan, C scan, what's that? And sometimes you have another name. I told you there is a wave that you send to the with the transmitter to the object and you receive it. You first have a static image of it. When you're above exactly perpendicular object above the object, you have a trace, which is called the A scan. And the A scan, you have a change of dielectric. What is dielectric or the permittivity is the characteristic of the material. And that's good when you have a big change of it, like concrete to metal or metal to air or air to concrete, which makes actually moving the amplitude on the A scan. And if the amplitude is negative in general in a concrete, it's a good sign that it's a metal. And when it's positive for standard concrete, it's a good sign that it's plastic or something else or air. And you can play with the color of amplitude. to design the B-scan. And the B-scan is combination of different A-scan. That's why you have this hyperbola, because you have, you know, many trace, many A-scan to color to make this technical view that we call B-scan. And it can be called also raw data view or non-migrated view. So it's longitudinal section. And you have this very appreciated by non-expert, because you can actually see the object very quickly. We call it migrated view. It's a more understandable view. Okay.
Hey, Hussam, sorry to interrupt. I have a question. Do you know what people in Canada, what their favorite scan is?
Oh, tell me. I don't know.
The A scan, eh?
Oh.
That's a pretty good scan, eh?
Yeah.
Sorry.
That's a nice one. That's a nice one.
I'm full of these bad jokes, but I'm sorry, but let's keep going.
Well, we shall not forget our Canadian friends. They have also huge. And then when you combine B scans, you know, longitudinal section, you have like many. You can actually have a nice what we call C scan, which is actually a mere 3D view of what you collected, and you can slice it as you want. You can also travel from the top or see it in 3D view. That's amazing. But for that, you need to scan as an area, not like a line scan before, because a line scan will produce only A scan and B scan. Here, you need to have different line scan to have an area scan. So you see, it's not rocket science. It's complex, sure, but you can learn very quickly the terms from the beginning if it's explained very well. Okay, now let's explain what we call cross-polarization. That's super terrific, super nice, super useful. If you turn simply the antenna that I explained before 90 degrees rotation, you align the transmitter and receiver, and you make it very nice to detect actually deeper objects, which are shadowed by the top object. So here, I give you an example of super clean data that we have from our sensors. Here, a typical tendon, so PT duct, that you cannot see with the normal line scan. If I cross-polarized, I see really better. Okay, this is called here cross-polarization. Okay, that's cool, that's nice. I have my antenna. No, it's not finished. You have some difficulties. You have a lot of issues to handle. First, the frequency. As you know, the biggest frequency you have, the small object and shallow layers you can detect. If you want to detect big object deep, you need a low frequency. And during many decades, you had to choose, okay, do I have to buy the first one, the second one? You know, do I have to focus on the shallow object? Of course, you need to focus on all objects. I mean, this is concrete, this is serious in the construction industry. And you need to have all those set of frequencies. And unfortunately, during many time, you had to buy several antennas. So that's the first, I would say, difficulty that you have. The second is the dielectric value. I explained to you it's linked to the concrete, right? If I have a dry concrete, so dielectric of 4, for instance, I will have a big rebar appearing and deep. If I have a very humid concrete, typically a young concrete, for instance, or a concrete which has a problem of infiltration, you will have a small object appearing, and that's the same object I'm talking about. Can you imagine? It will appear in shallow layers. And if I'm in the middle, like on the left, for a dielectric of 7, which is called the standard concrete, you know, not too humid, not too dry, then my object will appear in the middle with a medium size. You see the problem here? I don't know the dielectric. I don't know macro dielectric. I cannot really picture well my object. I cannot place it, you know, if it's deep or shallow. That's an issue, okay? The only thing you're sure there is something. Okay, cool, I know, but it's not enough. The other issue is the attenuation of the wave. Okay, unfortunately, the waves are not traveling forever in the universe. It will be absorbed, its energy, and the energy will be absorbed with the object and by the concrete depth. And you have also the shielding issue. I explained to you in the cross-polarization. You can be hidden by an object on top of your head, that's an issue. How to handle that? You had a clue. Cross polarization can help you for the shielding issue. Attenuation, you will see after. Another issue, and with Darrell, we spoke a lot about this. Many antennas, unfortunately, they remove what we call the background. They remove it by default, and they don't give you the option to activate or not. I will explain to you why it's a problem. Background removal, what is that? It's simply the effect of the wave, starting from transmitter and going directly to receiver. I picture it here, you see? And the problem, it creates a kind of annoying layer that you have in the shallow layers close to the surface, which is called background. And you see, it can hide small objects on shallow layers. What should I do, right? I need to remove it. Cool, wow. But you notice something, right? Hey, an object disappear, right? A longitudinal object disappear. It can be a pipe, a PT duct. And that's the problem many antennas have today. They removed by default their background. That's not cool because you can erase many objects. I will show you the solution is to have actually possibility to remove or not. Another issue is the noise cancellation, which comes from your iPhone or Galaxy, Samsung, or whatever. It can come from any Wi-Fi network. It's really annoying because you have some scar, that you see here in this sketch. It can really affect your data. And I can tell you, even some bad quality antenna, they have also internal noise. And that's an issue because they activate by default the noise cancellation. That's fine, but just to tell you that the noise can come from different sources.
Sorry to interrupt again, Hussam, but I saw in your last slide the animation wasn't playing to quite show the detail of how we can really go through and take care of that noise cancellation and all those things. So
I will show you after. It's not a problem. I will show in other data and real data. Here it's fine.
Yeah. Well, okay, perfect. Thank you.
Now the time window. Darrell announced a nice gift that we have today for you. You made the effort to attend to this webinar. And that's why you need to understand why we will propose a better penetration depth for GP1000. It's based on the time window. What is the time window? That's the time the receiver will listen, okay? So you give time to your receiver to listen the waves back coming from the object. If you have a short time window, unfortunately, the wave going to the deeper object will not go back to the receiver because you open your ear in a too short time window. So you need to have this possibility, and which does not exist today, right, Darren? No antenna, no handheld concrete scanner can give you the possibility to play with the time window and to go deeper in concrete or to focus on the shallow layers. So the time window is a problem because today, by default, most of the antenna, they propose you one fixed time window. Okay, so Darrell proposed, already showed you, we have a very nice ecosystem, 3 wonderful sensors, wireless. You can always use the cable for noise environments, and you have the possibility to process, to visualize in a such nice manner on site with the iPad. And you have the cloud for backup all your measurement files. Okay, so I told you about the frequency dilemma. Guess what? We have the STEC frequency continuous wave, and we were the first to launch it in 2017, right, Darrell? You were there, I'm sure.
I was
and
here.
It's 7 years well proven, and I'm pretty sure our friends, concrete scanners, they are all satisfied about it. No need to buy an army of antennas. One of the 3 sensors is making the job wonderfully. You have the big frequency, like 6 megahertz for the GP88. You can go to low frequency also, 200 megahertz with the GP1000. But you see, it's super wide in terms of frequency. You don't have to get worried about which frequency. You can really map all the objects, deeper or shallow. And again, 7 years now were proven. And it's standardized. We comply with all regulations, no worries on that. And all authorities now know and recognize, acknowledge our sensors across the world.
And of
Now,
course, the US being the last to adopt that. So yes, we're now fully approved in the US. All frequencies are go.
exactly. And now that's the gift. Have the pleasure to pre-announce, because it will be available in Q2 as early as possible. I can promise we're working hard for that, to release that. You will access to 1.50 m, which is around 60 inches for a dry concrete with GP8000. Now, who will benefit? It will be all people having the license for GP8000, the Pro, and all people who bought the advanced suit this year or in the future will get this nice improvement. Is that the good news for you, Daryl? You were expecting for that, right?
I'm excited about this. Yes, sir.
I will
I've
explain to
been waiting
you.
to tell people about it just for you to do it. So
I'm sure. And I will explain to you how to use that test after. Okay, the GP8000, Daryl explained to you, that's the really one in terms of ergonomics. You can scan vertically.
well, and the one thing I will say, Hussam, to piggyback off that 60-inch depth penetration, that doesn't come through the hardware. That comes through our software. We do everything through software, which is amazing. So we're not going to ask you for any more money. We're not going to ask you for anything extra. Simply update your new app and you get the 60 inches. That's it.
Exactly. And we have a so nice signal processing here and the powerful software with the computing power of the iPad. As Darren mentioned, you have it. No need to buy another hardware.
I always tell everybody that, hey, when you buy one of our sensors, and it sounds cheesy, but this is the last GPR you should need, because everything we do is going to come through the software. Take care of it, don't break it, make sure it works, and everything you have and everything that comes in the future will come through the software. I'm not going to call you and tell you about the newest, latest, and greatest. We're just going to update the software, and that's yours. You already paid for it.
Thank you, Darren. And the GP88, I think Darren mentioned it. It's very popular in US in building for Mars, because you can have it in your backpack. The resolution is amazing. You can also use cross-polarization. And then you have the last one, which was launched in 2021, which is the multi-line array, 6-line scans. You can really scan in very fast manner, because you have what we call the super line scan, and you can see directly 6-line scan. So you have more to get your object, and the rebars are visible very quickly. So the software here, and that's what we call advanced solutions for GPR world in construction industry. You have so many views available in the field directly in a super clean, super nice visualization. As I mentioned, the A scan and the B scan, you have it. You have also the migrated view. You have also all the plan view, the C scan that we call with the 3D view, and also the time slice view that I will explain in many examples. And you have also the augmented reality. So here, for instance, that's a typical measurement file. That when you scan after, any line scan, you have the B scan, and you can also access to the S scan. We made it, easy for you. You have the envelope. Typically, the envelope, you don't need to know if it's positive or negative, the amplitude. You just take it as a reference to mark the object, and you have many tags to categorize your object. And if you want to distinguish between metallic or plastic, you can check on the green amplitude here on the left. If it's negative, it should be metallic. If it's plastic, it should be positive. So here the peak is negative, you see the rebar, and the envelope is also helping you. And you have this nice visualization of the B-scan. So we have a very easy drop-down menu, settings, tags, and logbook. I will explain to you what. First, the attenuation problem, you can use this image processing, which is AutoGAN. If you're not expert, AutoGAN will help you already to have a good visualization of the object, or you can manually adjust the linear gain or the time gain compensation.
I think it's also important to note that these settings can be done before, during, or after. So if you need to adjust your gain before, during the scan, or after the scan, you can always come back into your scan and adjust those.
Exactly. And as I said, you can categorize, reference all your object with super nice tags. You can choose from library or define yours. And you have access also to LiveWire, which is available for GP8000 and GP8100, which is a signal strength giving you a hint of the presence of LiveWire. Time slice view, what's that? That's a really cool feature. Why? Because you can, B-scan are nice, don't get me wrong, but sometimes you have so much complexity inside the concrete. If you have the possibility, depends on your expertise, because we have, right, Darren, we have guys around which are super good with only B-scans. Fair enough. But sometimes you need to have a 3D view or a time slice, a C-scan, as I called it before. So you have the possibility to slice as you want with the slider on the left and go down or up. So you're traveling within the concrete thickness.
Correct.
That's really nice. And I will show you some nice examples from our partners or friends in US. You have the logbook. Today data are important. You need to enrich your measurement, like the probe information or geolocation, photographies, photos, text, voice notes. That's something you can access always on the right side of the iPad. It's very, very nice as an interface. No complex, no buttons. You work really with the state of the art to be productive. Now, you remember about the direct click issue? I told you that direct click, you need to know the dielectric of the concrete. If not, you will have crazy data you don't know. It's not accurate. The position in terms of depth and also the size. So you have the possibility with the software to first manually adjust it. If you know it, that's possible. Okay. If you know, because you know the concrete characteristics, or you can use what we call hyperbola fitting. That's really a nice feature. You go to some object and you fit, with the hyperbola in yellow, you fit on the real hyperbola that you have, and the dielectric will be adjusted following that.
Correct. And this is very easy to be done. If you look at the tab that says dielectric constant, all you have to do is move that tab back and forth, and the yellow window will fit into your hyperbola. And again, just like all the rest of our settings, you could do this after, during, before. It's very important, though. We want you to make sure you have the right dielectric constant, but it's very easy.
And I give you also another tip, another way to adjust the direct click. This one is also super precise. If you have a cover meter with you, typically, because we have a big ecosystem, you can take the cover meter from us. Don't need to buy another display on the iPad. You have the app, it's PM. So the advantage of eddy current cover meters is that the precision is really, really super precise. And by taking the position of the object from the profile meter, the cover meter, you can use the tag, okay, on the GPR app to position and recalculate the dielectric from it. So if you know the position of one object, typically a rebar, thanks to the cover meter, you can adjust it. That's another way to really have an accurate concrete direct click. So you remember the noise, Darrell, you were mentioning, the noise cancellation. Many antennas, they say that they cancel the noise because some antennas, they want to hide their default, but we don't compromise with that. We want to be transparent because first we have clean signal, and we want always to give the possibility to the user to play with the noise cancellation to see really the effect. Okay, I see some noise, I cancel it, and I can see the effect on the right here. So that's really one of the weapons that you have in image processing. You have so many possibility here to increase, to enhance the quality of your data. The background removal I explained to you before. Here I would show you a case where it was really useful to use it, because you can distinguish rebars. You will see in the video. But I really want to warn you guys, the background removal should be always an option that you can play with, because you have many background removal by default in many antennas in the market, which are applied, which also will delete longitudinal objects which are hidden below. Okay, so in this example, the background removal was activated to really help, because it was horrible on the top. You see the background was hiding rebars. So here on the migrated view and non-migrated view, you see that the hyperbolas and objects are more visible thanks to the background removal. So you see here, it's horrible red line, background removal, you see your objects. Okay. Now, again, I'm getting back to the nice gift that we have done today, offered to you guys, this pre-announcement of the adjustable time window. That's the name of the feature, and that's the feature helping you to reach 60 inches. How does it work? You will go simply to the image processing, you know, where you find your nice noise cancellation, background removal. You will find a depth time window in nanoseconds. So here, for instance, I have 10 nanoseconds. Cool. Okay, I can go probably to 30 inches, depending. Okay, I'm focusing on shallow layers, small objects, but I want to go deep, right? Daryl, I want to see object. Maybe there is something there. There is a pipe or something, you know? Guess what? You can now. You can by increasing the time window. Look at here. I increased from 10 to 16 nanoseconds. And now I'm going to 24 nanoseconds. And you see there here an object appearing on the super deep layers. This is what we now propose to you guys to increase your certainty, precision, productivity as well. Is that cool, Daryl?
Do I have to buy a new unit for this, or how do I get this new feature?
Simply, you need to have a GP 8000. Maybe you have already one license for GP 8000, you will get it, or you need to purchase one, and you will have it on the software as well.
So just download the newest app, right?
Exactly.
Correct.
I want to talk about resolutions here on the GP88. Again, a very, very successful antenna product for you guys. I know in many buildings where you need to mark. I just want to remind you, many antennas, you know, in the market, they give you one hyperbola. So you guess one rebar, and it's wrong. With high resolution, you can see really that there are two rebars in many examples. And unfortunately, we see many antenna pulse GPR, for instance, they don't really give you the possibility to distinguish rebars, you know, between each other. Also, reminder that GP88 is cross-polarized, so you can do it. So I explained to you before. Here we have super clean data. You can see on the left, I can see my rebars on top. Hey, and start to guess there is something there, maybe a PT duct. How shall I do? I take only a few seconds to turn 90 degrees, the GP88. I scan on the same direction, and I can see my tendon very well, my PT duct. That's really a powerful feature that we have here for the GP88. GP81, that's a hoover, you know, of objects with 6 line scans, or here we have 6 line scans A, B, C, D, E, F. You have directly a plan view when you scan, So from the top, you have your rebars appearing. And if you want to B-scan, fair enough, it's still there. Just select one line scan among the 6, and you will see the corresponding line scan with the hyperbolas. And that's a powerful one to see really directly a plan view from the beginning on one pass. And it's very, very appreciated for people who scan, on bridge deck or large slabs like parking on office buildings. Now let's talk about use cases from our US colleagues and also from Asian colleagues. So here, just want to show you the power of step frequency continuous wave. So don't pay attention on the interface here. It's just that the antenna is lifted in the air. So the scans was repeated 3 times. And what we could see actually is we could find the post-tension beam, deeper below the concrete slab. And it was possible thanks to the step frequency continuous wave and also the signal processing. That's a very good example here where you can see some beams. And another example is the hollow core concrete slab. I know that it's very successful, popular hollow core now for 50 years, I think, or even more in all offices, because you can have a big span because it's a light efficiency, in terms, because you have air inside the concrete slab. The problem here is that many people scanning hollow core concrete slabs would say, oh, that's the rebars, right, Darrell? Oh, that's rebars, right? Here. And no, that's not rebars. If you check the A scan, if you listen what I said before with the amplitude, a positive amplitude, going to more on the, on the air. So it's not negative, it's not metallic. So here, thanks to the A scan and also the pattern of colors, I don't want to comment here because it depends on your preference, but here it was air and not rebars. So
I will say it looks like Lucas has really good penmanship, the way he drew his annotations in there.
Exactly.
Lucas has great penmanship. Look at him.
You can always annotate with the software here. And,
yeah, the annotation. So to touch on the annotation, if you see at the bottom right, there's a pencil there, and you can always come in and circle things or make remarks to things or just see, this is important in all of your scans. So when you upload that, it will always be there.
Exactly. So that's a good example where data clarity matters to understand what's going on there. So obviously here, if you're a driller, you would drill on top of hyperbola. Yeah, it looks weird, but you have to do that because it's air and not metallic object. Another example, which is cool, it's an example of here of corrosion assessment on the slab grade in the medical center. You have actually, the good news is that corroded rebar dissipates the GPR waves and returns less energy compared to the healthy steel rebar. And then sometimes, and be careful, that's not always the case. You can have some shield, but here there is no shield close to the surface. It's a big clue here that those rebars that you see here have a corrosion issue. Always, please check with other solutions like half cell potential that we also propose in our set of different sensors, or you can have also destructive tests, to confirm it. But you see the importance to have a good signal processing and visualization on your iPad. You can really distinguish healthy rebars with corroded ones here in this example.
GPR insights would also help with that, correct, Hussam?
Exactly. If you want to push more and have really an overview, accurate one and a massive one, you can use GPR Insights, which is a software solution in post-processing that we also can propose you if you're interested. Here, 3D view, always cool to have it in a structure assessment. Here, it's an example in Singapore. It was a footbridge. They wanted to check if 2 layers, it was homogeneous. No, the contractor did not cheat, by removing some rebars. So that's an example if you want to play with the colors and see the 3D view. Here, it's a nice example from Rory Foley. Is that your friend, Darrell, from Cobra Concrete Cutting Services?
He's a good friend of mine. Yeah, we talk a lot. Yes, sir.
I can tell you this example is one of the best I've ever seen. It's a heating system in a concrete slab. So you have the snake pattern hot water pipes, and with a time slice view, so traveling in the thickness, Rory was able to see it. What an amazing job. I'm always watching it. So let's take a look.
Yeah, this
So
was using the 8100.
The top, then
But yeah, see the, yes.
Exactly. You see the water pipes snake pattern. That's super nice because if you want precision here, which is whatever, if it's structure assessment or coring, you need to have this precision, you know, for liability issue and also damage, heat prevention. That's really, really important. And to finish, we have a nice example of Singapore building office push tension concrete slab. Here in this example is the same with the time slice view. So area scan with GP81, you could actually see the PT duct, which is also another sensitive object you don't want to damage. So let's see it. Let's watch it. So you see the top rebar, and then you will see the PT duct appearing in the middle. And then you finish with the bottom rebars. Again, an amazing job.
Right, and that's in our 2D slice view. So in our slice view, you can literally pick, say, centimeters or inches, however short you want, and slice through the concrete and just see everything in a single layer, which is very important when it comes to some of the congested slabs.
Okay, so here you can introduce, I think it's a testimony, right, Dara?
Yeah, my man Rory.
Cobra has been a loyal ProSec customer for the past 4 years. Our owner went to World of Concrete and came back and told me about this GPR unit that could not only do area scans with unbelievable detail, but also could do AR. And you know, being the skeptic I am, I was like, okay, let's see, let's try it out. So I called Paul up from ProSec Screening Eagle. He came out to a job site for me, and you know, immediately I was amazed, not only by the functionality of the exports and the C scans and everything that goes on with that, but also just the B scan clarity is kind of amazing, and the depth penetration. So we had run the unit next to our other fleet units that we had from another company, and the difference between depth penetration was almost double. Now that's because of the step frequency continuous wave that the units use. You're able to not sacrifice depth penetration for signal clarity. The way the app stitches together the data is just unbelievable. Another thing that's great about using ProSec products is the ability to take the data and clean it up. You could take a data set that doesn't look particularly great when you first run it, maybe in auto gain mode, and clean up the image so much so that you're seeing stuff that originally you didn't see when you first started scanning. So those really hard to read jobs where you got a lot going on, it's just a great tool to have. Now when it comes to super complicated slabs and having the ability to collect large format area scans and be able to look at it that way, another amazing function of that when it comes to the GP8100, being able to collect data on 1 foot centers in both directions and do up to like a 30 by 30 grid in less than an hour generally. Just unbelievable I don't think really any product on the market could match it.
So to put proof to the pudding here, what we're going to do is now show a video of someone collecting data with our GP8100. And again, like he said, it's 1 foot centers, so you only have to go 1 foot, X and Y direction. So I believe our next video here is going to be of someone collecting that data, one of our local guys, Patrick Baldwin. So enjoy. This is Patrick. So he's slicing through again, time slice. He's picked, I see 1/4 of an inch. So he just wants to make sure to slice through and see every layer. So you're slicing through the concrete at every layer, is what he's doing currently. And you see the tendons in there and the whole grid. And then what he'll eventually do here is open up the window so we can see the whole slab. But again, here you go back through. I mean, how great is it to see those actual tendons coming across, as well as the rebar grid into the software. This is our augmented reality. So essentially he's gonna just show it to it, and where he scanned, that's actual data right there. So he can now see that. So say you're in front of a general contractor or anyone else, and you said, hey, I told you there's PTs going through here. Well, I mean, they don't know how to look at hyperbolas, correct? So now they can come in and look at this view right here and say, oh, well, I can make sense of that. Anyone can make sense of that. Lift it up, pull it out of the concrete. I mean, our augmented reality is amazing. The hard part in this is literally just collecting the scans. Like Rory said, 12 inches on center. Collect the scans, X and Y, and you can create this yourself.
Great. Okay. So can we start the questions?
Yeah, Q&A. What do you guys got?
Okay. There's one interesting question. Are the software built in the GPR? Maybe you can reply to that, Dara.
Which one? I'm sorry, what is it?
Is the software built in a sensor?
Oh, yes. So the software is an iPad. So every GPR needs an iPad. If you have an iPad, that's your brains. The best part about an iPad is it does everything your phone does. It can take pictures, it can take voice memos, it can do everything. So don't take for granted having your tablet as or your iPad, excuse me, as your screen. But yes, the software is built in. So every GPR comes with the software. So the GPR itself has a Wi-Fi dongle. The Wi-Fi dongle goes directly to your iPad. You connect for the first time, and then they're best friends. From there on out, you just connect, scan, whatever you would like. And all the software is built directly into your iPad. So if you want to share, you want to create reports, you want to do anything, it's all right there. It's all built in. Everything is included.
Okay, I would take one question, which is interesting, is the precision. Let me find the question. What is the smallest size it can detect or the largest size it can miss? Okay, I will give you some accuracy tolerance that we can find in our website, in FAQ website page, if you go to GP1000 or other. So the depth accuracy is plus minus 0.2 inches or 5 millimeters for metric guys. Of course, you have to adjust the dialectic as I showed you. If you don't do that, forget about those plus minus 0.2 inches. Okay, that's the best one if you use our software and use the possibility that I presented before. In terms of accuracy in distance, it's 2% in error in distance. And the minimum distance between objects, which is interesting to know, for GP8000 and GP8100, it's 1.6 inches. And for GP8800, the 88, is 1.2 inches. And which explain what I called resolution. The GP88 is really the best to resolve the distance, to give you the best accuracy for the distance between objects. Okay. Darrell, here, what is the difference between SFCW and all other radars in the market?
Oh, that's wonderful. That's a good question. So pulse radar is really good at, so historically, everyone used pulse radar. So if you guys can see me, pulse radar would be really good at a certain frequency. So let's call it 2000. So 2000 is really good at going down this far, finding this, and then does its best ever along the way. So with step frequency, I'll take it, the GP8800, for example. We go from 400 megahertz to 6,000 megahertz. So the way that works is the higher the megahertz, the better the resolution, but it won't go as deep. So the GP8800, 6,000 megahertz, might go an inch or two. Okay. Behind that, we do 5,970, 5,940. Small increments. This is nanoseconds. So what we're doing is all the frequencies we have are happening in one pass. So instead of focusing on 2000, we're focusing on everything. So not only are we super clear at the top of the surface, we also have the best depth penetration of anyone in the market. It's just a better science. I don't know. We are better at seeing data, not only shallow but deep. So step frequency sees every single frequency along the way instead of focusing on just one.
Okay, I also have many questions. Sorry if I don't, but I summarize many questions which ask the same. For this new adjustable time window, so higher penetration depth, 16 inches. First, is there any subscription? I mean, people are asking about, so maybe that's good to clarify here that actually today, yeah. Go ahead, Darrell. Maybe that's good to.
Okay, so currently the way we sell this model is there's an annual subscription to get the upgrades. Moving forward, we are going to sell this as more of a one-off. We are going to sell this as you buy the product, you buy the software, and all is well. So the price is going to be more than it used to be, of course. But instead of paying me an annual subscription every year, you can pay me one time, and all the greatest features that we have are going to come your way.
Exactly. And for some of you who still have a license, you pay annually, you will automatically benefit. You will have this time adjustable time window automatically. You will have it. So no worries on that. And if you want it in the future, as Daryl explained, you can have now a one-off offer. So you can in one-off access to GP1000 and the powerful software GP app.
And you saw, I know it sounds corny, and I always tell everybody this. Hey, I'm going to hit you with a corny sales, here I come with a corny sales pitch. But as long as you keep your piece of hardware, so here's your hardware, 8,000, 8,800, 8,100. As long as you don't break that, as long as that's, ready and working, you're always going to have the latest and greatest GPR. I mean, it comes through the software. All of our upgrades are going to come straight through the software.
Exactly. I have a question here. Does cross-polarization work every time? Well, first, when you have it, so the GP88, for instance, that's a great advantage because you, especially in closed area, very congested, you can really start to see all those objects. But what we notice is that, also for physics reasons, the longitudinal objects are more visible. So if you have a hidden longitudinal object below, it's better. You can really increase the clarity. For perpendicular, shielded by perpendicular object, it's a bit more difficult, but cross-polarization at the end, it's just an improvement. It will just unveil better, some object. But you cannot like unveil 100%. It's for sure you need it. It's a must to have it, especially when you work in congested areas in buildings, for instance. A question, maybe the last one for you. Can I share files in real time, Daryl?
Oh, that's an easy one. Yes, of course you can. So our GPRs work off of a iPad. So it has to be iPad, has to be Apple. But with that being said, as simply as you can send a text message, you can share files. So I know historically, and I'm ignorant myself. I've only worked with my GPR, so I don't realize how user friendly mine is. But with an iPad, I mean, simply my data, click of a button, I can share that with whoever I want. As easy as you can send a text or an email, you can share a GPR file. You can share a GPR report, our HTML. So alone, our HTML report, I call it a report, but our HTML is a report. For 9 out of 10 people, it's as good of a report as you're going to use. It's amazing. You just collect the data, take a couple notes, could put a couple tags in, maybe add a picture in the logbook, and then the HTML, boom, is as good of a report as you're going to make. Say you have someone in the field and they are super confused, have no idea what's going on. We have the ability to share via URL. So URL means the exact scan and data I just took. So I collected data and I see an anomaly that I'm not sure what's going on. I can click a button. I can share that with my GPR expert. I can share that with myself. I can share that with my team of technical support, which is amazing. And all of us can look at that together. We can all get on our iPads. We can adjust everything and figure out what the heck's going on. So the software is huge. I mean, it's literally like you're on site, you're never lost. It's, if you have something out there and you don't know what the heck you're looking at, send it to me. Send it to your GPR guy. Send it to my specialist. We're here to help. And it's easy. I mean, it's like sending a text or an email. It's that easy.
Exactly. And I know that during many decades, people were struggling to protect their data and, okay, USB sticks help a bit. But if you're on site, you need to get on the office to Hopefully you didn't break your USB stick or it works well. But as you said today with the cloud and sending through internet connection, so 4G, 5G, it's very quick. 3G if you want, or a Wi-Fi connection in a McDonald's, it's done.
Correct. Yeah. I mean, you don't have to have phone service. I mean, we recommend it, but you don't have to have it. You could always hotspot your iPad to your phone and then send it. It's not necessary, but it would be, again, I think it should be preferred.
Great. Anyway, guys, we keep in touch. We always we are with you. If you have any questions, you can contact us through the website, or here we have some email address, or you can also follow up with the if you ask for a demo, we will be happy to demo you anything. Also to to teach you a bit, to train you, because when we demo, we always share the knowledge as we did today. And yeah, Darren, you want to end here?
I'm looking forward to hearing from some of you folks here in the US. I'd love to come through some demos and teach you what you're doing or what we're doing. I mean, it's truly impressive. I don't come from this industry, and I love it. I see what we're doing, and I see the way we're making things better, and it's truly impressive.
Thank you, guys. Thank you, Darren, and take care. Have a nice day or good afternoon.
Take care, everybody. Thank you. Thank you for attending.
Recording